everyone. We are UTrustPack company from China, a packaging solution provider worldwide. Now we have an Italian customer who needs a sachet packaging system, and we would like our production manager, Mr. Lee, to tell us what this system about. Mr. Lee, could you tell us what the customer wants from us?
This project is a solution for an Italian customer who is mainly engaged in the OEM production of healthcare products. The customer's product is automatically packed into the bag through the multi-row bag packaging machine to complete the inner packaging, then manually counting and packing into boxes to complete the outer packaging. Because outer packaging requires a lot of manual work, and due to the current epidemic situation, it is difficult to recruit local workers. So the customer wants to reduce the need for manual labor by improving the automation of the outer packaging process.
Thanks, Mr. Lee. Now we know the customer needs customized automation sachet packaging solutions from us. Could you tell us what sort of difficulties we need to deal with to match the customer's special requirements?
Since customers are OEMs for healthcare products, they have a wide variety of products. We have received quite a few different types of products from the customer, and there will be new varieties added in the future. The size and length of the sachet range, 25150, and the width range, 4150. The inner boxes and the number of sachets corresponding to each kind of sachet are also different, and the number of sachet varies from 10 to 30 packages. Different types of sachet have different requirements for inner packaging. Some sachets only need to be packed in a sufficient quantity, and some sachets need to be packed in a sufficient number and the same placement direction. The production efficiency is about 300 to 500 packs per minute according to the size of the sachets. At present, the traditional sachets counting and packing equipment, the sachets come out from the multi-row sachet packaging machine and are sorted into a single row and uniform direction by means of guiding conveyor belt and multi-section conveyor belt acceleration and enter into the counting machine. The counting machine divides the sachets into the tooling according to the set quantity and then pushes them into the tooling of the automatic box opening and box feeding machine. The automatic box opening and cartoning machine then pushes the sachets from the tooling into the inner box to complete the packaging process of sorting, counting, and boxing. The traditional equipment is very mature for the automatic counting and boxing of one single kind of package, but the traditional equipment also has great limitations. The traditional sachet sorting equipment can only arrange the chaotic sachets into a single row without overlapping, but there is no way to unify the direction of the printed patterns on the sachets. The counting machine cannot be compatible with any number of counts, and the compatible count values must be multiplied, such as 6, 12, 18, etc. 6, 7 are not compatible. The automatic box opening device can only be compatible with one or two kind of boxes within a certain size. The customer needs our sorting and packing system to be compatible with various sizes of sachets, various counts, and some sachets need to be placed in the box according to the direction of the unified printing pattern. Traditional equipment cannot be compatible with all requirements, so the difficulty of this project is to meet these compatibility requirements at the same time.
Right, compatibility seems to be a common issue in this industry. So comparing with the traditional sachet sorting system, could you tell us how to solve this compatibility of these three major issues: the sachet size, the number of counts, and the proper placement?
The customer's sachets are in a disordered stacking condition. When they are sent to the packaging workshop, it is necessary to preliminarily sort out the sachets and separate the sachets one by one. According to the customer needs that different types of sachets need to be put into boxes in different quantities. The counting device adopts a solution of vision plus parallel manipulators, compatible with any counting number. At the same time, the direction of the pattern on the package can be visually recognized, and the manipulator can also place the sachets in a uniform pattern direction while sorting and counting. The manipulator picks up one sachet at a time and places it in the discharge tooling according to the set quantity and the unified pattern direction. Since the automatic box opening machine cannot be compatible with large differences in size, and the two ways of placing the sachets vertically and horizontally at the same time, we finally abandoned the idea of automatic boxing system. The sachets are remaining to be packed into boxes manually. This project includes 3 parts: the disordered sachet sorting mechanism, the counting and sorting mechanism, and the output mechanism. The disordered sachet sorting mechanism. The disordered sachet sorting mechanism is composed of 2 parts: a multi-stage vibration plate mechanism and a multi-stage acceleration lifting mechanism. The disordered sachets are first vibrated and separated by a multi-stage vibration mechanism. The vibrating plate is folded with wave grooves. While vibrating the sachets, the direction of sachets is straightened as uniform as possible, and then the sachets are getting into the multi-stage acceleration lifting mechanism. The sachets are further separated by their own gravity and the differential speed between the rollers of each lifting section, and enter the counting and sorting part along their respective channels. The counting and sorting mechanism, it is mainly composed of stainless steel rack, 2 incoming conveyor belts, 6 sets of vision systems, and 6 parallel manipulators. The parallel manipulator is commonly known as spider hand. It is characterized by high action efficiency and high repeatability. The action efficiency can reach 120 times or min, and the repeatability can reach within 0.1 millimeter, which is very suitable for sorting and arranging small objects. The vision system is responsible for locating the coordinates of the sachets and distinguishing the direction of the sachets pattern, and sending the coordinates and direction information of the sachets to the manipulator. The manipulators pick and place according to this information, rotate their corresponding angle, and then place the sachets into the discharging tooling conveyor belt. There is also a sensor at the end of the manipulator to judge whether the placement is successful. If the placement is successful, the count of the discharging tooling is increased by 1. In this way, with the cooperation of the vision and the manipulator, the unified direction sorting and counting of the sachets is completed. The sorted and counted sachets are transported to the back through the output mechanism, and then the sachets are manually packed into boxes.
Alright, let's talk to our computer vision engineer, Ryan. Hi Ryan, since you are in charge of the computer vision in this project, could you explain how it works in this program?
Hi Maggie, thanks for having me. Our computer vision system works with Delta Robot. Delta Robot have small inertia, net singularity, and cross-chain kinematic calculation can be very fast. This means very fast speed and accuracy for picking and placing. Our vision system sends coordinates of the target and commands the robot to pick the sachet. The deep learning algorithm can capture the minute details, so we can identify the front, the back, the head, and the tail, sort of a 4-degree of freedom identification.
Great. Why is a challenging problem to us?
This is a very challenging problem though, not like self-driving car. Neural networks do long-tail object detection and classification. For our scenario, Delta Robot's vision serves industrial manufacturing, which really demands stability and robustness with affordable computational hardware. We have this feature of 4-degree freedom identification of the sachet. This is very challenging. Ordinary computer vision is struggling to accomplish 4-degree freedom identification. We have to capture not only big features, but we analyze all the small features on the sachet. The colors, the edges, the colors, the motifs, the local patterns, the holistic ingredients should be all sent to the neural networks for some tricky processing. And bingo. Keep in mind that we're talking about 99% accuracy. This is absolutely our killer feature. We're so proud of this one. B. The system should be robust enough to handle different reflections on the sachet. Because the sachet surface is very smooth, we'll always have a lot of glares masking out the important features. This causes the object detection unstable. We came up with a lot of tricks and solved this problem. C. For 1 degree freedom identification, only identify the coordinates of the sachet. Our customer demands high generation ability. In other words, when customer wants to switch product, we do not need to do the network training again. Deep learning model always requests gazillion amount of sample data to achieve high generation ability. This is not a practical approach. We solved this algorithmically without stacking more layers on neural nets and annotating more data. So what does this mean for our customers? Customers can switch product on the fly. There's no too much downtime of the production. For 1 degree freedom feature, customers don't need to pay extra money for model training. Simply put, for small and dense sachet picking and placing, we always offer our customers extra more features with inexpensive price. So we can always catch the sachet and deliver the value.
Catch you later.